guys, so far we've been talking about squaring when you multiply a number by itself. So you guys know like the perfect squares are whenever you have a whole number times itself. So like 5 squared or 5 times 5 makes 25. 6 squared or 6 times 6 makes 36. And so the opposite of squaring is taking a square root. So for instance, if I say what is the square root of 9, that's equal to 3 because 3 to the second power is 9. Or if I say, what's the square root of 36? That's 6, because 6 to the second power is 36. So, since we already know about the perfect squares, I wanted to up the game a little bit today and have us talk about the perfect cubes. So, when you square a number, you multiply it by itself. When you cube a number, you multiply it by itself and then by itself again. So let's look at a few of the perfect cubes. Okay, so like 1 to the third power. That's 1 times 1 times 1, so that's just 1. All right, 2 to the third power. That's 2 times 2 times 2, so that's 8. 3 to the third power is 3 times 3 times 3, so that's 27. And I could keep going with this list for a while. I'll tell you that 5 to the third power is 125. I'll tell you that 10 to the third power is 1,000. And you could use your calculator to generate even more of these. But the real reason I bring this up is not just to show you how to cube. You guys already know how to do that. It's to do the opposite of cubing. So if the opposite of squaring is to take a square root, the opposite of cubing is to take what's called a cube root. So a cube root is asking the question, what cubes to make this number? And so the deal is when you do a cube root, it will look just like a square root, except there will be a tiny little 3 right on the edge of the root. We call that the index of the root. So a normal root with no index written there, you're assuming it is a square root. But if you see a little 3 right here, it's a cube root, and that's saying what cubes to make this number. So for instance, the cube root of 125 would be 5. And that's because 5 to the third power makes 125. And if I asked you, for instance, like, what is the cube root of 8, that's saying what number cubes to 8, that number would be 2, because 2 to the third is 8. So cube roots are just like square roots, except they're looking for a cube instead of a square. It means they're not always as easy to do in your head, but we're going to basically go over how all the strategies you guys already know for square roots, you can apply to cube roots. So let's remind ourselves of all the different stuff we have been practicing with square roots. So one of the things we've been practicing with square roots is if you have a problem like the square root of 50, something where you don't know exactly what that square root is. So I've told you there's 2 things you can do. You can approximate it using your calculator, or you can simplify it by making a tree. So as a quick review, if I approximate this using my calculator, I just put into my calculator square root of 50, I'll get about 7.1. And if I simplify it, making a little tree, I would see that 50 is 25 times 2, or 5 times 5 times 2. And I would say a pair on the inside makes 1 on the outside. This simplifies to 5 times the square root of 2. Okay, so what does this look like for a cube root? All right, so here's an example. Let's say I asked you guys about not the square root of something, but the cube root of something. Let's say we have the cube root of 24. Just like with the square root of 50, that is something that you can approximate using a calculator and that you can simplify by making a tree. Now, using your calculator for this is a little bit confusing. What you have to do is you have to push the math button on your calculator. So I'm going to press the button that says math, and that gives me a whole lot of options. You'll notice you have an option. The 4th option is a little cube root. So the 4th option on the math menu is a cube root. If I take the cube root of 24, I get a weird decimal, goes on forever. It's about 2.8844. So this approximates to be about 2.88. And what does that mean? Well, it means if you did 2.88 to the third power, you'd get about 24. So this is a number that when it cubes makes 24. In terms of simplifying this, here's the good news. You use exactly the same process you would with a square root. That is to say, to simplify the root, we want to make a tree. So 24 I know is 4 times 6. So 2, 2, 2, 3. I bet you guys can guess what's different here. When I did a square root, I was looking for a pair on the inside, like 5 squared on the inside. When I do a cube root, I'm going to be looking for a triple on the inside, 2 cubed. If you have 3 2's on the inside, that makes 1 2 on the outside. So this simplifies to regular 2 times the cube root of 3. You do need to make sure that when you simplify a cube root, anything left under the root is still underneath a cube root. Because a square root and a cube root are different. Like, the square root of 2 is not the same as the cube root of 2, for instance. So, you can use your calculator to approximate, and you can simplify by making a tree, pull out a triple to make one regular number. All right, and then how about the other types of problems that we've been doing? Well, let's do a series of examples. All right, so first example that we're going to do today, let's just simplify the cube root of 56. Okay, whether it's a square root or a cube root, you want to start by making a tree. 56, it turns out, is 8 times 7, and then 8 is 4 times 2, this is 2 times 2. So I notice I have the cube root of 2 times 2 times 2 times 7 with a cube root, 3 on the inside. A cube on the inside makes 1 on the outside. So this simplifies to be 2 times the cube root of 7. That index on the root can be really, really tiny. It's just a little thing letting us know this is 2 times the cube root of 7, not 2 times the square root of 7. Okay. Other skills that you can apply here. Let's say I asked you to do a multiplication problem where I had 2 times the cube root of 3, and I said, let's multiply that times 5 times the cube root of 9. Okay, so just like we learned with square roots, you can always multiply a regular number times another regular number. You can always multiply a root number times another root number. So regular 2 times regular 5 is going to make regular 10. Cube root of 3 times cube root of 9 is going to make a cube root of 27. Now, you might recognize cube root of 27. You might be like, oh, I know something that cubes to 27. But even if you can't do that right away, it still works to make a tree here. You could say this is 9 times 3, 3 times 3. So I have 10 times the cube root of 3 times 3 times 3. Because 27 is 3 times 3 times 3, this can just make a regular 3 on the outside. So I have 10 times 3. Nothing is left underneath the root. This just becomes 30. And the reason nothing is left underneath the root is that the cube root of 27 is exactly 3. 3 cubes to make 27, so the cube root of 27 is just the regular number 3. This just becomes 10 times 3, or 30. Okay. Now, not every multiplication problem will turn out quite that nice, and that's fine. So, like, let's say that we were asked to multiply, for instance, the cube root of 6 times the cube root of 20. Well, since those are both cube roots, I know I can make this into the cube root of 120. And I don't know any number that cubes to 120, so I can just make a tree. I can say, okay, that's 6 times 20, 3 times 2, times 2 times 10, which is 2 times 5. And if you just look at this list here, I have 3 2s, a 3 and a 5. 3 2s on the inside makes 1 2 on the outside. And then 3 and 5 are left inside. And I just want to multiply those together. So this is 2 times the cube root of 15. All right. What else have we done with square roots? We've added them. So let's say that I gave you a problem like the cube root of 40 plus the cube root of 5. So the big message from last time's video is that even though it's really easy to multiply and divide square roots, you can always like multiply a root by another root, you can always divide a root by another root, that doesn't work with adding and subtracting. So what you remember from the last video is that if we are adding and subtracting, we do not just add the numbers. Like this is not going to be the cube root of 45. We cannot do that with roots. So the message from last time is that if you have roots, you need to simplify your roots and then combine like terms. Same deal with cube roots. So cube root of 40, I know that that's 8 times 5. So 2 times 4, 2 times 2. Cube root of 40 is 2, 2, 2, 5. 3 2's on the inside becomes 1 2 on the outside. So if I was to rewrite this, this is 2 times the cube root of 5 plus the cube root of 5. And so, guys, this is just like a problem where you have 2x plus x. Like, the cube root of 5 is a strange root that I don't know exactly. It is a number that goes on forever and ever and ever. It's very gross. So it's a lot like a variable. It's a lot like an unknown. So if I have 2 weird things plus another weird thing, 2 weird things plus 1 more weird thing, this is going to add up to 3 of the weird thing. In this case, the answer to this question, 2 times the cube root of 5 plus the cube root of 5 is 3 times the cube root of 5. All right. Maybe one more example, and then I'll let you guys do some practice problems with cube roots for today. The last thing I wanted to do is just compare squaring and cubing. So this last problem is going to have a part A and a part B. So these are going to be 2 problems that look really similar, and I just want to point out the difference between the 2 of them. So let's say that we had 2 times the cube root of 6, and I cubed that. And then let's say I had 2 times the cube root of 6, and then I squared that. So just practice with working with exponents. Okay, so the good news is you can always distribute an exponent over multiplication. So basically what I need to do here is just cube both of these things. What I need to do here is square both of these things. So for this problem, I have 2 cubed times the cube root of 6 cubed. Okay, well, 2 cubed, that makes 2 times 2 times 2, or 8. And then here's the deal. This is really nice. Just like squares and square roots are opposites, so they always cancel, cubes and cube roots are opposites, so they cancel. So if I have the cube root of something cubed, that just cancels to become 6. This problem becomes regular 8 times regular 6. It just becomes 48. For part B, by contrast, I have 2 squared times the cube root of 6 squared. All right, so the first part's easy. 2 to the second power is 4. The second part, what I want to point out is squares and square roots are opposites, but cube roots are a totally different thing. Cube roots are not the same as square roots. So these 2 things do not cancel. This just has to turn into cube root of 6 times cube root of 6, which is 4 times the cube root of 36. The square root of 36 would be exactly 6, but the cube root of 36 is stuck. There are no triples under there. So that's as simplified as that gets. Okay, guys, good luck with your homework, and I will talk to you soon.